Good morning, everyone. Thank you for joining today's webinar, Reimagine Service Delivery Using IoT and AI. This webinar is jointly hosted by Accrete Solutions and Equip. Highlight of today's webinar will be insights and talk by Derek Binkley, Director of Technical Services, ARCA, about how they leverage the IoT AI solution to solve their service challenges. Before we start, I would like to go over a few housekeeping items. If you have any question during the presentation, please type them into the question box in your GoToWebinar control panel. We will bring them up during the presentation, and we will also have time for questions at the end. This webinar is being recorded and will be sent to you following the presentation for your own purpose or to share with others. Now, I would like to introduce today's presenters. Ashish Saxena, he is Vice President at Accrete Solutions. And we are delighted to have Derek Binkley, Director of Technical Services at ARCA, and Ramki Pichwar, CEO, Accrete. We will start this webinar with short poll. Our first polling question is, I will request you to respond to these questions. So our first question is, what are your IoT and AI plans? Okay, our next question is, which CRM software do you use for service? You have options. Okay, and here we have third poll question. Do your devices have sensors? And here we have last question. Which software do you use for spare parts planning? Thank you so much. So we will share the responses with you after the presentation in a follow-up email. And now I will hand over to Ashish to start today's presentation. Ashish.
Hi, good morning, good afternoon, everyone. This is Ashish Saxena. I'm the Vice President of Accrete Solutions, and I'm responsible for delivering ERP and CRM solutions. We as a company have been involved with CRM for the last 15 years roughly, and we have been doing service implementations, end-to-end service to cash implementations. We worked on different areas in service like parts planning, field service, depot, factory repair, call center, preventive maintenance, service billing, installation, etc. We worked in different verticals as well, like high-tech medical devices, heavy equipments, etc. And we also have business experience. That means, some of our team members were working in the service business space, before becoming, being involved with integration, or become system integrators with integrating AI IoT solutions with SAP and Salesforce and Oracle, etc. That's a quick nutshell about Accrete Solutions. Ramki, can you go ahead and introduce yourself?
Thanks, Ashish. Good morning and good afternoon, everyone. This is Ramki Pichwaya. I'm the founder and CEO of Accrete. Accrete is a prescriptive service application. And our focus is how we can transform the existing service operations using what we call as a system of intelligence layer. We work with the existing workflows, existing processes, and deliver using the predictions and prescription what the service team can do in terms of making the operations more efficient, and also driving both the service as well as the direct product sales. With that, I want to turn it over to Derek Binkley, and he's one of the customers of Accrete. Over to you, Derek.
Hello, everybody. Thank you, Ramki. Yes, my name is Derek Binkley. I am the Director of Technical Services here at ARCA. ARCA is a cash automation device manufacturer, as well as full-scale service and support. So I oversee the service group in the US, and I've been utilizing Accrete, and we've been partnered with them for just about 2 years. We've had significant development and improvement over that time. We went fully live in the environment utilizing Accrete as our one of our solutions about a year ago in January. So that is my story, and we've been a good partner and really enjoyed working with Ramki and his team, and we're improving every day.
Thank you, Derek. I'm just quickly going through the agenda. We'll cover the service challenges and complexities, and we'll talk about what are the IoT and AI ML solutions we offer, and how do we integrate with ERP and CRM. And then we'll talk about customer case studies, primarily focused on ARCA, and then a couple of other case studies as well. And then we'll have a question answer session. So going to customer relationship, customer relationship is a key component these days, and it seems, as per Forrester and Gartner, the CRM software revenue or CRM software sales is going to grow exponentially, and service is a key component of CRM. I mean, service is really the face of the company, because the number of interactions made by customer service or field service is pretty high. So the quality of work they do is very, very important for having a happy customer. If a field service technician goes to a customer site who's not happy because the machine is down and is able to fix the machine in the first visit, that is definitely a happy customer. Similarly, if you make a customer call for a technical issue, and that issue gets resolved in the first call itself, instead of being transferred from X to department to Y department or callbacks, etc. Again, you're having a happy customer with potentially additional business from them. Again, on the same lines, the demand on service organizations is increasing. There is higher customer expectations, and even companies internally expect more from the service organization. I mean, if you look at it, there is software as a service, there is platform as a service, there is content as a service, database as a service. Everything is pretty much becoming servicitized, or whatever you want to call it. The business models are going towards more service-oriented models. And then service, which used to be a cost center in the past, has pretty much become now a profit center. And that's what every company wants, that there should be revenue being generated from service. In fact, if there's a lot of focus on bundling products. You bundle physical products and you bundle warranty and maintenance and sell them as a service, basically based on usage, etc. So some of the challenges which service folks have and complexities, and I'm going to cover a few of them. So the first one I'm going to cover is spare parts planning. So imagine, large companies like Caterpillar, who have multi-million dollar machines, or even KLA Core, or even Intuitive Medical in medical device and high tech. They have high-value machines, and they have millions and millions or thousands of parts. And Caterpillar, for example, is a global company, and they have multiple manufacturing warehouses. There are multiple distribution warehouses, and they would have multiple parts warehouses, again, in each country. And then you will also have multiple field service technicians who will have their trunk stock, and they may have third-party service providers who will also have parts as well. So, the parts can be manufactured by Caterpillar, can be manufactured by third-party vendors, and then they could, and parts could have different versions. So part A could be replaced by part B could be replaced by part C, etc. And then you could have high-value parts. You could have which you really can't stock, or you can stock in specific places. And then you could have fast-moving parts and slow-moving parts. You could have a customer who has got a very high SLA, which means you have to stock part of the customer site as well. That is another scenario which has to be taken care of. So how do you forecast and plan for such parts? You really need proper inventory. The right parts at the right place at the right time, and you need to decide how much do you want to stock at each location, or each of the warehouses, or in each trunk stock. So this is where the spare parts planning solution from Accrete can potentially help, and Ramki is going to talk about that shortly. Similarly, going on to preventive maintenance, the preventive maintenance is really based, like your car, as an example, is based on a counter, which is, or a duration. So it could be 10,000 miles in a year, or it could be, or it could be 10,000 miles, or it could be 1 year. Now, whether you drive the car at all, like I have two cars, I drive one probably 2,000 miles a year, and other one probably 20,000 miles a year. But the service period is the same. So this results in unnecessary maintenance, which is not really required, unnecessary cost, and it may result in failures as well, because you try to do a PM and that resulted in a failure. So that's a typical model which has been done in the past, but the new model is based on predictive maintenance, which essentially means that you do the maintenance based on the condition of the car. The older preventive maintenance was based on a theoretical rate of failure, and it did not account for actual equipment performance. So, what you have is you have various sensors, like a pressure sensor, you have a vibration sensor, you have temperature sensor, etc., which monitors the condition of the device, and then it can help you do predictive maintenance and preventive maintenance. Again, Ramki is going to cover that on details about that solution. And then the last one I will talk about is connected devices. So service has generally been reactive in the past instead of being proactive. So, how can we make it proactive? To get the right technician with the right skill set, with the right tools, with the right parts, and avoid repeat visit is what everybody would want in the service team to have, as well as the customers would also want to have that. And typically, according to a research conducted by Service Council, 77% of the time, the fixed rate, there was a first-time fixed rate. So 23% of the time, you have the technicians going for a repeat visit, or there were no parts available, or the tool wasn't available, or they did not have help from a technician. The other challenge which is there is for service is embracing these new technologies. So you have these technologies of IoT, machine learning, artificial intelligence, and virtual reality or augmented reality. How do you leverage these technologies and build processes, business processes or service processes, which makes the service organization more efficient and better. And that's where I think our solution is going to help you. I mean, our goal is to provide a solution which works with these technologies and integrates that with backend ERP, CRM, or supply chain solutions. And with this, I will hand it over to Ramki to talk about more details about the solution.
Thanks, Ashish. Clearly, we articulated the challenges that service team face. And the whole thesis behind Accrete is how can we use the AI and machine learning so we can look at what has been deployed in the field and look at the pattern of how these assets are performing and how the technicians are both call center as well as field techs are working, and how the parts are being consumed. And clearly, if we can understand the nuances or the pattern, intricate patterns we call it, that can be more focused, and then we have an opportunity that we can essentially democratize the way that companies execute today, and improve the quality of service, also drive both the revenue as well as the customer experience from those. So clearly, if you look at almost all the companies globally, the field techs are, it takes a long time to train somebody there. And the challenges that many companies are facing is the technicians' turnover is becoming higher, the product life cycle becoming shorter. So by having these two challenges, and is it possible that we can use in a complementary way through human guidance, but really having a ML way of extracting the proper things so that we can help the technicians, we can help the logistics teams with the right parts management, we can help the call center to really solve the problem very quickly. So that's the thesis. And how we do that, we are looking at the data that is coming from the assets as well as from the internal systems that are processing them. Once we get them and we have a unique way of looking at these data points and look for the patterns and anomalies. From these, we generate some forecast signals for parts, technicians, and the problems and where things are coming. And we can also see, for in some cases, you may have to account for the lead time, replenish time, receive time. So you have to manage these things, whether the tech is available or not. If a particular job can be solved by 2 techs, which tech is better? So these type of forecasting that we can extract out. Clearly, any machine learning will have its own variance, its own incorrectness. Well, we call it, sometimes it generates false positive signals. So what we have to do, what we have done is we not only learn, we also test on an ongoing basis, so we can account for these variances and reduce the error and then drive the predictions quality up. And finally, we are able to take all this information back into the way that service organizations would want to look at the P&L and bring that proactive operational decisions. So how we are able to do in a way is described in, is within the Accrete. So number one, we have a model, we have multiple machine learning models, but we do have a metadata that is very much of a device ontology specific. So based on the types of devices that we are managing, we are able to have apply the type of model that we need to do. And in fact, our meta model can be configured to suit for the devices that we are trying to manage. And typically, everybody looks for, today, if you look at the best practice, we all look for that time-based approach. What we have is a unique model, we call it MWBF. It is mean work between failure, with W being a very multidimensional thing. So we look at multiple signals. I'm just going to rattle out a few sample signals that pretty much will be obvious for a lot of people. Where the asset is, who is using it, who is servicing them, what type of firmware it is on it, what type of sensors are built in, what type of data or critical data that is coming from these devices, and what type of field work was done. what's the age, where is it, what's the environmental factor, all those types of things, we're able to take it and then apply. But all these things are just back-end model execution. But at the end of the day, the customers want to know what, how, and when type of things. What should I do, when should I do, and how I'm going to do. So we translate all these things based on the type of questions that we need to answer, bring them back to these answers or time dimensions, back into time dimensions so that we can provide them, and constantly evolve from there to learn from emerging data, new data that is coming in. And with that, we also supplement this with a lot of machine learning approach of clustering technology and pattern recognition, all those type of things. And we're able to also take the transfer learning from one set of modeling to another set of modeling, and we are able to integrate them back into workflows. Clearly, the question is, so this solution would require you to have a lot of hardware to be put in and streaming data. And clearly, if you look at it, the service has been working for many, many years. A lot of people have assets in the field for a decade or so. What that means is, what we call is, we want to work with connected devices. The requirement is, as long as we're able to track the work that's being performed on those devices, as long as we're able to get the data on a regular pattern from these devices, we should be able to work. Clearly, there is a large movement towards IoT, having more sensors and streaming. So we have examples where we're able to even get the sensor data in real time, where we can take those data and look for the pattern anomaly and drive predictions. Of course, having a sensor is good, but we know that customers go through the paradigm of having connected assets, mixed assets, and then go through the IoT paradigm. So how does this solution, if you look at it, last umpteen number of years after the ERP, CRM worlds, the whole focus, we've been always focused on how to make our internal workflows more efficient. So that is the way the systems are today designed. We are now switching how customers want to see the experience of those things. If we can answer the customer-centric way, we can translate the intelligence that we're able to see and influence back into workflows, is what the big difference is with Accrete-like solution. That way, we are able to optimize the service operations based on the patterns. We don't have to say, you know what, I have to manage all these assets. We have to do the preventative maintenance every 3 months or 4 months. We can now look at how it's being used and localized, unique pattern, and then drive them back, as an example. We also be able to get the early warnings, because it is, if you look at many of the business intelligence tools, we always look backwards. Hey, what happened last month? What happened this quarter? What happened this year? And we use that as a way to do a future planning. Here, we are able to see what is happening in the field, in the way the customers are using, in the way they are connected to the depots, and we are able to see what needs to happen from parts, assets, and tool inventory issues. We're also able to see the impact on what is going to be to my P&L, so that we can manage them better. And how do we do that? So by doing all these things, we have a module, because it's a complex, like Ashish was talking about. You have to think about the issues that are coming from there. You have to manage the assets. We have to manage the technicians, all these things. So what we have done is, we have modularized the whole Accrete solution into various things. From the time an incident comes from the field, there are models that execute to figure out, based on the previous history, what the pattern of root cause would be. And based on that, we are also able to quickly assign. Today, for example, it takes 28 minutes to assign a rep to a problem. With this type of solution, you're essentially making it to 0. So we're able to take those problems and understand what the root cause, get the right rep assigned. On top of it, based on the past historical solutions, we're also able to figure out what the solution that might work best for this. By combining these and also adding the intelligence on the existing assets in the field, we have a device module that starts to work towards which devices are going to have a problem in the next, let's say, 30 days. Or if it's a real-time issues, next 15, 20 minutes. And where we should be paying attention to. That way, we are now going to be, we don't have to have a challenge of today, the workflows are designed, let me get the best tech available now and then send a person, right? This way, because we know where the problems are going to be, what type of problem that Accrete is pretty intelligent enough to not just say this asset is going to have a challenge, it also will go the further down, this type of a component within the device is going to have a problem. By having that, we are able to find the right person with the right skill to deploy that. Now, that's where the technicians come in. Now I know where the challenges are. I know the capability of our technicians and the availability of the technicians and the skill sets. We can now start to look for the right type of technicians to work on them. Given that I know where the signals are coming from, where the anomalies are coming from, now we're able to even manage. We don't have to always do a rapid shipment of parts, or we don't have to do a couple of times rework at the same customer, come back. We don't have to over-replace. One of the customers that we work with, because the time is pretty sensitive, so when there is a problem, there is a new challenge of over-replacing. So instead of part A needs to be replaced because they don't want to come back and they want to make the thing very good, so they just replace part A, B, and C. So how can you avoid that? And those type of things that we can do. Clearly, each product goes through multiple life cycle. When you announce the product, even if it is it's an early system of having some sensor change or a firmware change, there's an early part that you have to manage through the warranty period, and there is a stable state, and then toward the end of the state. So by having the pattern, we're able to recognize those things and advise them. So how does it work in an end-to-end solution? So I'm going to turn it over to Ashish so he can talk about how all these Accrete is integrated with the rest of them, and they've done some work on this, and he will explain that.
Okay, so we have, if you look at it, we have the devices on the left-hand side, and we have the AI ML IoT engine, which is basically the Accrete engine. And we have a CRM system, could have an ERP system, we could have a supply chain management system, you could have all of them. But for the AI ML IoT engine to work, you need to provide it with key data and historical data, so that it can use that for prediction and planning, etc. So you provide material inventory, you provide parts usage data from the ERP system, and you also provide service history and install base or serial number information from the CRM system to the AI ML IoT engine, and that it will use that for basically generating a forecast, or provide that forecast to the SCM solution. It doesn't have to be SCM. If it is SCM, or you could use ERP as well. And that will help help you generate the spare part forecasting, which would by warehouse. So that would help you in improved and a better efficient forecast. And as I explained earlier, you have a bill of distribution is like, how do you distribute the parts in different warehouses, and how much do you store in each warehouse? And a warehouse could be a parts warehouse, could be a manufacturing, could be distribution, could even be a field trunk stock as well. So that is how the forecasting or spare parts planning solution works. Then you could also have device data, being sent over from the devices. So the devices would have sensors, different kind of sensors, as we talked about earlier. They will feed it to this IoT engine, and that would, so if a device is about to fail, it can send the information to the IoT engine, which will then trigger a service ticket creation in CRM, and that would then result in the technician being sent on site and then performing service there. That would reduce the time for the service. The other thing which you could do is since you have access to all this data from the sensors, you could use that data for usage billing. So you could have this all this large volume of data. So if you had, for example, a mine which could have 50 mining machines, and each the way you invoice a customer is based on the earth removed per day, and for each machine. So you pretty much have to track how much earth was removed every day for every serial number of the machine. Similarly, for another customer, it could have been based on the usage of forklifts. They use the forklift 4 hours a day, or 24 hours a day, or 8 hours a day, and they could have 100 forklifts or maybe 500 forklifts, etc. Those kind of scenarios are getting pretty common, and then you could use this usage data to invoice. This usage data could also be used for improving product quality. Since you have access to the device, you could provide quality data, from the sensors back to ERP, which can then use it for improvements in the product itself. Another advantage of this is that you could, since you know customer behaviors, you could potentially recommend or generate additional revenue generating offers and offer the customer additional options or additional solutions which could benefit them. So that, in a nutshell, is what I would describe as a solution which works with CRM and ERP solutions. I mean, from a technical standpoint, that you can integrate that using web service calls, or you can use middleware. And we've pretty much used both the solutions pretty commonly, and worked across SAP CRM and ERP solutions, Salesforce solutions, Oracle solutions, etc., and integrated it across different middlewares as well. So now I'm going to move on to case studies, and I will hand it over to Derek, and he's going to talk to you about how this solution helped him. So Derek, over to you.
Great, thank you. Yeah, just a quick overview of ARCA. We are a global cash automation company. We're headquartered in North Carolina. This year, it's our 20th year in operation. Our flagship product is the CM18 Teller Cash Recycler. It's the most widely deployed cash recycler in the world. It's primarily in banks and financial institutions. We have different areas of operation and financial. We have OEM and retail channels. So financial is our primary, or my group's primary area. The cash recyclers in that environment. We have a full footprint in the U.S. We're in all 50 states, including Alaska and Hawaii. We have about 600 or just over 600 certified field technicians. They are all third-party service partners, so not ARCA employees. But we do have an installations and technical support group that are entirely ARCA employees. And that's pretty much covers what we do. So we are we're doing all the support, post-installation support and technical support, and working with the software providers, and mainly supporting the hardware aspect of our cash recyclers. Just to kind of go over what our model is and where Accrete's been able to take us. So looking at the best practice today on the model, historically we had kind of a preventative maintenance approach that was more time-based or frequency-based. So as Ashish was saying in the beginning, that we kind of developed this. We're going to go out and do PMs regardless of whether they're needed or not. And at this point, we've moved with Accrete. We've been able to move to a reduction in overall PMs, and just doing them as we've been looking for what we say a PM with a purpose. So we go out there. We have the prediction where we expected the device to fail within 30 days, and it will tell us the area, kind of narrow down that area. So our PM manager and dispatcher is working with our third-party partners to open that ticket. Typically, they get them done within 2 weeks or less. So we we have kind of that, it gives us that time window that we can get out there and resolve the issue, exactly what the issue is going to be, and do it ahead of time. So usually we're about a week or two before the anticipated failure will occur. So that's definitely from a customer standpoint, it's been a bit of a difference as far as downtime. Obviously, that's the first. We have an increased uptime by doing fewer PMs, and as well as the PMs that are going to be, exactly where they're needed. So that's been a very beneficial standpoint, and especially with our third-party providers, we've been able to reduce our overall on-site dispatch rate with this. So here's just kind of an example of some of the downtime analysis we've conducted with one of our larger customers. Back in the spring of this year, we did looking at the PM with a purpose, 2-hour scheduled downtime for a standard PM versus if we go in and we wait for the machine to fail, we're looking at about 4 hours. If we need parts, all of our parts are shipped out next day air for emergency break fixes. So being able to convert that to shipping parts, second day or standard ground shipments we've seen a significant savings there. But overall in unscheduled downtime, we've moved from the 6 to 8 hours into a 2-hour scheduled downtime where the tech can arrive on site with the part that they need in advance. So we've taken a look at this particular analysis, 222 devices, just run off of our top 50 prediction for February. We were able to save 1,822 hours of unscheduled downtime just by moving from the wait for the failure to conducting a PM with a purpose. So translating to almost 23,000 hours annually that we can avoid.
Okay.
That is excellent summary, Derek. Thank you. And what we wanted to do was, clearly present various options. We constantly are in discussions with very, very innovative way of thinking with several customers on how they can leverage machine learning. For example, let's talk about this one. So this is a flow manufacturing example. It's a contract manufacturer. They essentially produce 800,000 widgets a week across 4 different lines. And what happens is every 3 seconds, there is a product that comes out of these lines. And the important thing is even few minutes of downtime would make a big impact in the production. And if you translate that even to the customer revenue, it's huge, multiple millions of dollars, even on a daily basis. And what Accrete, we were able to do with Accrete was to take these information from the sensor themselves from across these lines and figure out, and few things we did. We were able to direct the operators that are working on it for set of problems before they happen. In the next 15 or 20 minutes, what's going to happen? So that they can direct the resource, number one. They don't need to have too many operators. Direct them, first of all. Number two, because we know the type of problem that's going to happen, they're also able to reduce any downtime. For example, the alignment of some of these things, the material has to come in. It may get realigned, and this can reduce that. So the result is driving the OEE up significantly. Good percentage. That 5% means a lot of money, and get the operator efficiencies. And on top of this, rather than having a PM, which is a long time window that they have to do where all the machines have to be brought down, this type of model does not remove the PM, but really drives, like Derek says, it's a PM with a purpose and also compressed PM. So both of them driving the value. So that's one example. In fact, I was having a discussion with the New Zealand company just last week, and they are innovative. Everybody loves PG fruit, and they have built robots that not only knows when to pick these fruits because they use computer visioning, they also know how to pick them and drive the efficiencies, and also not just picking them, and they have to pack and ship and control over time. And all these different things that we are now working with them on, how to improve that overall processes, how we can drive overall efficiencies, and not to have a problem during the transit. The next example is about discrete systems. If you go to the next one, Ashish, it's about the medical device. So it's one of the largest medical device companies, and we looked at the data for 5 years, and they have different models. And biggest thing that we saw multiple different things. One, based on the symptoms that are described by the customers, and a lot of time got spent to figure out what the root cause is there. And then once the resolution is in place, and they're able to direct the technician so that the person can go and then solve it. This solution is able to, because it doesn't replace the human, it helps the human so that they can spend less time trying to figure out what the root cause is. So we're able to compress that time, number one. Because we know how the parts are being used and consumed in various parts, we are able to look forward and say, these are the assets, this is where the consumption is going to happen. Because it's not just deciding how many parts are going to be needed. You really have to map that with the customer association, customer to depot association, depot to hub association. So all these different things that you have to look at them in high value parts at the depot level. So we're able to do that and then drive the accuracy in the demand. And finally, we're also able to get way better warning before the problem happens. Very similar to what Derek was explaining. So we have a lot of examples of this sort. And just yesterday, I was with a customer where they have it's manufacturing systems, and they have systems where they have to use a filtering system along with a heated element to wash the product and then make sure that it is defect free to come out. And we can, even those, one of the things that, you have to address them all. Even the filter replacement, and if you have the timely replacement of filter, will save them a ton of money in terms of, because anytime they have to replace a filter, they have to take a good amount of downtime. And because of that, they also can't delay the filter replacement, because if you delay, then the whole thing goes bad either. How do you optimize that? Things of that sort they're going to be using Accrete for. So with that, I think we probably covered quite a bit, and if I think it'll be a good time. I'll turn it over to AJ so that we can start to answer some of the questions.
Thank you, Ramki. We are now going to begin answering the questions. So the first question that we have, I have a customer support portal. Can I still use Accrete? Derek, maybe if you could share your perspective, because you are using Accrete.
Yes, absolutely. So from ARCA's side, from our support group, we are using a portal. Our system goes pretty similar to what we were looking at earlier. Our ERP system that we use is Infor-LN, and that's where the ticket is generated and then pushed over to our home developed portal that we call ARCA Care. So the ticket goes there, and then the technician in the field fills that out via a mobile form, their service ticket that details everything from the call, including the response time, the resolution, details about the repair, everything, the parts that were used. It gives them goes through kind of a checklist of cleaning the machine and just some standard processes to remind them, down to a rating of the machine. So from there, all of that data is collected from the portal into the database, which is where Accrete then ties into that database and provides the information that we use regularly.
Thank you, Derek. So another question that we have, How much of training data needed to train the AI engine? 2 years data versus 5-year data. How structured it has to be. So, Ramki?
Yeah, so it's a pretty loaded question. So in fact, one of my colleagues, she has written some article in Forbes, and I think the next article is actually on this exact question. I think that I don't know when that's coming out. I think Forbes is going to publish that article and that'll answer. So the quick answer is, if you go to any data scientist, they will just say, "Give me lots of data." And what we have done is that if you look at 2x2 kind of a matrix, and if you look at on one side x-axis, what we call is the variety of data. On the y-axis is the amount of data. What we have done is we call it a Goldilocks moment, which is as long as balance the time and the variety of data is more important than just having a clearly large sets of data or clearly too much of the variance. So we look at them and we want to be able to see most of our models is on supervised learning method. So it's essentially wants us to know what has happened in the past, both positive and negative cases. So as long as we have that, that's one thing. So it all depends on, in a case of where the streaming example that I was just talking about, we don't need years of data. In fact, we just need, for the original model build, we probably were looking at multiple months. But as the learning happens, we tend to have a lot more weights on the recent changes because things degrade differently, etc. So the models are pretty intelligent to pick those signals. I think there was a second question, Ajay, on that. Is what was the second part? I forgot. Sorry. Can you repeat it?
Yep, just skip it. So, how structured it has to be?
Yeah, this is a very fantastic one. So it depends on the problem statements. When we are looking for a problem that is being reported, nobody puts it in a very structured way. So they're all going to describe differently. In fact, I'm just giving a very simple answer. I turned the power off, or the power got turned off. Though people use different types of describing the same problem, and for example, in some cases, I cannot send mail or I cannot send an Outlook. So all these different ways of describing the same problem. So there we have models that can pick up this unstructured method to figure out what the intent could be and what the problem category where we can correlate the problem. But other things which are more, we also have structured where, the CRM or data sets where we do look for structured information on what, when the field service was done, what was done, which technician performed, etc. So the answer is both, depends on the problem.
Sure. Thank you, Ramki. So another question that we got is, which problem should I pick to resolve? So,
that's another loaded question. If you look at it, there was a circle diagram where we were talking about, we can look at the incidents and then try to manage those at that level, or we can manage at the parts level, we can manage the asset level, or a warranty or parts technicians, etc. So typically, I'm going to partner with Derek. Maybe Derek, you can also add to this. But typically, what happens is that we recommend pick an area where there's going to be an ROI quickly. Don't try to do all the areas. Once we fix one area, we can always add on and then drive them. Maybe you can start with incident, then you can start with the asset, or you can start with the asset, then later on you can go to parts. That would be our recommendation. So I also want to hear, because Derek has been challenged with this in terms of how they want to use it. So Derek?
Yeah, yes. We started primarily with incidents as it relates to the predictive failures. And once we kind of, I guess it was a few months of developing the incident and really, improving that level of it, we kind of moved over into parts. So now that we've kind of have full confidence in the predictive part of it, of the incidents and assets, we're moving into other areas such as warranty and how to drive sales utilizing this. But yeah, if we only had one, definitely the incident from the predictive side.
Sure. Thank you, Derek. Thank you, Ramki. So with this, we are close to end of this session. Thank you, Ashish, Derek, and Ramki for sharing insights. And thank you, everyone, for attending today's webinar. You will receive a follow-up email with a link to view a recording of today's webinar. On behalf of Accrete, Accrete, and our presenters, thank you for joining us today, and have a nice day. Thank you.
Thank you.
Thank you all.